Okay, continuing on our polynomial functions lesson. If you take a look at these graphs, we have f of x equals x plus 1. That's a straight line heading up to the right. Here we have a quadratic, x squared minus 2x minus 3. We all know and have seen those before, heading up, only up. This is, by the way, concave up, the direction or the shape. Then we have a new function, x cubed function, and the x cubed function looks like this. Up, then down, then back up again. This is sort of heading in the same direction as that straight line. And then we have a fourth function. This is a quartic function, degree 4, that looks like it opens, or sorry, it starts up, heads down, up again. And notices that, or I noticed that the arrows on the ends are both heading in the upwards direction, similar to a quadratic. Very similar, actually. Just this extra little bit in here is different. So we want to complete the following table using that graph. Here is the table. X-intercepts. Where do we find them? 1, 2, 3, 4 x-intercepts at -4, -1, 2, and 5. Y-intercept, circle it up here. That's y equals 4. Number of critical points are 3. They are here, here, and here. There are 3 critical points where this graph changes direction. Number of inflection points, 2. One here, where it stops becoming concave up and starts going concave down. And another over here, where it stops going concave down and starts going concave up. Domain. All the possible x values, well, x can be anything from negative to positive infinity, as you can see. Range, anything higher than -8. So -8 less than or equal to y less than infinity. Type of symmetry we have here is line symmetry. Is it an odd or even function? No, it could be an even function, but it's not at x equals 0, so it can't be even. It does, however, still have line symmetry. End behavior. As x approaches negative infinity this way, y is heading up to positive infinity. As x approaches positive infinity that way, y approaches positive infinity. As the degree of the function gets higher, what do you notice? Well, there's a couple things I notice. When the degree is even, the graph opens up only, from Q2, for example, to Q1. So this is what I mean. Quadrant 2 to quadrant 1. Quadrant 2 to quadrant 1. When the degree is odd, the graph opens up diagonally, such as Q3 to Q1. I'm looking at an odd degree here, Q3 to Q1, quadrant 1 to quadrant 3. Here it starts at Q3 and ends at Q1, quadrant 3 to quadrant 1. So it looks like it's opening up. That's what I mean by opening up diagonally, heading up this direction. Rational functions. I want you to change this. It should have said 4 over x plus 2 for this graph. Can you change that now on your sheet, please? Here's a couple more rational functions here, just to give you an idea of what they look like. And I can see right off the bat that they don't look like what I just saw. Rational functions, it looks like, have asymptotes. These horizontal and vertical asymptotes is what a rational function looks like. So, completing the table from the graph above, we have an x-intercept of 4, a y-intercept of -2, 0 critical points, a vertical asymptote of x equals -2, that's this one, straight up and down, a horizontal asymptote at y equals 1, that's this one, straight across. We have a range of YER such that y cannot equal 1, that's the only y value that y is not allowed to be. End behavior, as x approaches negative and positive infinity, y is approaching that 1, that asymptote, horizontal asymptote at 1. There's also more, and I let you figure that out. As x approaches -2 from the right, and as x approaches -2 from the left, what does y do? I'll let you figure that part out. You can look at the previous lesson to help you figure that out. As x approaches -2 from the right, so that positive means from the right. So here's -2. I'm heading towards -2 from the right-hand side. What's going on? Well, y is heading down. As x approaches -2 from the left, we're coming in this way at it. What's y doing? As we come to the right, closer and closer to -2, it's heading up. For this one, x-intercepts, there are none. Y-intercept, y equals 3, it's right there. Critical points, there are 2 of them, one here, one there. Vertical asymptote at x equals -3, that's the vertical line here. There is no horizontal asymptote, but there is an oblique asymptote. An oblique asymptote, remember, is a diagonal line that a graph gets closer and closer to. The domain for this is xer, x cannot equal -3. That's the only value of x it cannot be. And the end behavior, as x approaches -infinity, y approaches -infinity. As x approaches infinity, y approaches infinity. As the end behavior here. There are 2 more, and I want you to figure this out again. As x approaches, and as x approaches. So there's a vertical asymptote at -3. So we have to figure out the behavior at -3. As x approaches -3 from the right, as x approaches -3 from the left. What is y doing? And I want you to figure that out for yourself. Next and last, we have 2 graphs here, and I want you to distinguish between the 2 and know how to distinguish between the 2. I'm looking at these 2 graphs, and I notice right off the bat that the second graph is the one that has asymptotes. I see a vertical asymptotes, I see a horizontal asymptote here. The first graph does not have any asymptotes. So this function is definitely polynomial. It has a y-intercept of 0, x-intercepts at -4, 0, and 4. Critical points, there are 2 of them. One is here, one is here. Inflection points, 1 right here. Type of symmetry is point symmetry, and that point happens to be right there. So that if we rotated this 180 degrees to the left, it would be the exact same graph. So therefore we have an odd function here. The domain is xer such that x can be anything between negative and positive infinity, and the range is yer such that y can be anything between negative and positive infinity, since it opens down and opens up. There are arrows on the ends here. End behavior is as such, and you can figure that out yourself. This function, however, when I notice that it has asymptotes, it must make it a rational function. A y-intercept of 0, an x-intercept of 0, vertical asymptotes at -2 and 2, a horizontal asymptote at -2, an oblique asymptote, no, none of those. Critical points, well, there is one, it's right here. It's where the graph stops heading down and starts heading back up again. No inflection points. It is an even function because it has line symmetry. Line symmetry cuts the graph exactly in half. And if you fold it over one side over the other along x equals 0, you'll notice it has an even line symmetry, making it an even function. Domain, x cannot equal plus or minus 2. Those are the asymptotes. Y has to be either greater than or equal to 0. There's this no man's land here that y is not allowed to be. It has to be greater than or equal to 0. That's one part of it. Comma, y is less than -2. Here's less than -2 because -2 is an asymptote. So very important that we write the domain and range correctly. Increasing and decreasing regions. Between 0 and 2, and between 2 and infinity, it's increasing. Between -infinity and -2, and between -2 and 0, it is decreasing. You'll have to go back to the brackets lesson to understand what I've done here. Make sure you understand what brackets I've used and why. And finally, for end behavior, as x approaches -infinity and positive infinity, y is approaching -2. There are other values as well that we have to test. As x approaches -2 from the right, as x approaches -2 from the left, and as x approaches 2 from the right, and as x approaches 2 from the left. We have to figure out all of those as they all contribute to this end behavior, not just heading towards negative and positive infinity. All right, that's it for this lesson. Hang tight for the next one, and I hope all that made sense to start you off. Please look for your homework to help you practice these concepts. Thanks.